Hello, we are America Ruiz Ulloa and Jose Maria Rendon Rodriguez, and this is Chapter 5, Ethernet. In this chapter, we're going to see the timeline of Ethernet, its characteristics, LLC, max layer, data encapsulation, media access control, CMSA, Ethernet frame fields, MAC and IP, ARP, LAN switches, fixed and modular configuration, and finally, Layer 3. Ethernet was invented by Xerox Company. Xerox, with the help of Digital Equipment Corp. And Intel, released a standard for 10 megabytes per second, with an Ethernet over coaxial cable. It has been changed from coaxial cable to twisted pair to fiber optic. Later, it was fast Ethernet over twisted pair and fiber, and it has been changed from 10 megabytes to 100 gigabytes. Ethernet is now the predominant LAN technology in the world, which operates in the link and physical layer. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet supports the next bandwidths: 10 and 100 megabytes per second, 1, 10, 40, and 100 gigabytes per second. Ethernet standards define both the Layer 2 protocols and the Layer 1 technologies. For Layer 2 protocols and 802.11 standards, Ethernet relies on the sublayers of the data link layer to operate, the LLC, and the MAC sublayers. The LLC handles the communication between the upper layer and the lower layer. The LLC subtakes the network data protocol and adds the control information to help deliver the packet to the destination node. The MAC sublayer constitutes the lower sublayer of the data link layer. MAC is implemented by hardware, typically in the computer and IC. It has two responsibilities: data encapsulation and media access control. Data encapsulation includes frame assembly before transmission and frame assembly upon reception of a frame. It consists in three parts. Frame delimiter provides delimiters used to identify a group of bits that make up a frame. Addressing: each Ethernet header added into frame contains a physical address that enables a frame to be delivered to a destination node. And error detection: each Ethernet frame contains a trailer with a cyclic redundancy check, CRC, of the frame contents. The media access control is responsible for the placement of frames in the media, and also for the removal of the same frames in the media. This sublayer, as we can see in the image, it communicates with the physical directly with the physical layer. The underlying logical topology of Ethernet is a multi-access bus, all nodes on a single network segment share the medium. If two people are trying to talk simultaneously, the data will collide, resulting for corruption in usable data. For this reason, Ethernet provides a method for controlling how the nodes share access through the use of carrier-sense multiple access technology. The CSMA process is used to first detect if the media is carrying a signal. If a carrier signal on the media from another node is detected, it means that another device is transmitting. When the device attempted to transmit sees that the media is busy, it will wait and try again after a short time of period. If no carrier signals is detected, the device transmits the data. The CMA collision detection, CD, if the data signal is absent, indicating that the media is free, the device transmits the data. If signals are not detected that show another device was transmitted at the same time, all devices stop sending and try again later. The traditional forms of Ethernet were developed to use this method. The CSMA collision avoidance. The device examines the media for the presence of data signal. If the media is free, the device sends a notification across the media of its intent to use it. The device then sends the data. This medium method is used by 802.11 wireless networks. MAC and IP. There are two primary addresses assigned to a host device: physical address, the MAC address, and logical address, the IP address. Both the MAC and the IP address work together to identify a device on the network. MAC address structure. MAC address must be globally unique. The rules established by EAA require any vendor that sells Ethernet devices to register with EAA assigns a vendor a 3-byte 24-bit code called Organizationally Unique Identifier OUI. EAA requires a vendor to follow two simple rules. All MAC addresses assigned to a NIC or other Ethernet device must be that vendors assign OUI as the first 3 bytes. All MAC addresses will be the same. OUI must be assigned a unique value in the last 3 bytes. Ethernet MAC. MAC address use hexadecimal numbering. On a Windows host, the ipconfig all command can be used to identify the MAC address of any Ethernet adapter. The MAC address is often referred to as the burn-in address, BIA, because historically this address is burned into the ROM read-only access memory on the NIC. This means that the address is encoded into the ROM chip permanently. It cannot be changed by software. MAC addresses are assigned to workstations, servers, printers, switches, any device that must originate or receive data or network. When a computer starts up, the first thing it does is copy the MAC address from ROM into RAM. Each NIC in the network views the information at the MAC layer to see the destination MAC address in the frame matches the device's physical MAC address stored in RAM. If there is no match, the device discards the frame. When the frame reaches the destination where the MAC of the NIC matches the destination MAC of the frame, the NIC passes the frame up to the oscillator where the encapsulation process takes place. In Ethernet, different MAC addresses are used for Layer 2 unicast, 1-to-1, broadcast, 1-to-many, and multicast, 1-to-all. Multicast address would be used in remote gaming and distant learning through video conferencing. Ethernet frame fields. The first Ethernet frame fields are the preamble of 7 bytes and the start frame of 1 byte. These are used for the synchronization between the sending and receiving the devices. In simple words, they tell the receivers to get ready to receive a new frame. The destination address. This 6-byte field is identified for the intended recipient. The address in the frame is compared to the MAC address in the device. If they match, the device accepts the frame. The source address is a 6-byte field that identifies the frame originally NIC of interface. The length field defines the exact length of the frame data field. This is used later as part of FCS to ensure that the message was received properly. And the headline data. It contains the encapsulated data from the higher layer, 46 to 1500 bytes, which is generic layer 3 PDU, mostly an IPv4 packet. All frames must be at least 64 bytes long. FCS field, or frame check sequence, is 4 bytes. Is used to detect error in a frame. Is used as cyclic redundancy check. The sending device includes the results of a CRC in the FCS field of the frame.
Eternal MAC. MAC address uses hexadecimal numbering on a Windows host. The ipconfig all command can be used to identify the MAC address by Internet adapter. MAC and IP. There are two primary addresses assigned to a host device. Physical address, the MAC address of course, local address, the IP address. Both the MAC address and IP address work together to identify a device on the network. We see there is the unicast with his IP of MAC, this MAC, source IP, this IP packet, Ethernet frame, and with the multicast we have the same steps and their communications with the multicast. Okay. ARP address resolution protocol resuming IPv4 address to MAC address, maintaining a table of mappings. ARP uses security. In some cases, the use of ARP can lead to a potential security risk. And LAN switches. Recall that the logical topology of an internet network is a multi-access bus. This logical topology determines how hosts on the network view and process frames sent and received on the network is completely transparent to network protocols and user applications. Fixed configuration switches. Features and options are limited to those that originally come with the switch. And modular configuration switches. The chassis accepts line cards that contain the ports. Layer 3 switching. Well, for Huawei information-based FIB, the FIB is conceptually similar to a routing table. With CIF, information previously stored in the route cache is stored in several data structures for CIF switching. Adjacency tables maintain the layer 2 next half address for all FIB entries. A trace port can be configured to a layer 3 route port and behave like a regular routing interface, specifically a route port being associated with a particular VLAN can be configured with a layer 3 routing protocol. This is a layer 3 interface only and doesn't support layer 2 protocol. Configure route ports by PuTTY.